Subnet mask, subnet masking or subnetting. So we are taking question answer on this. The first one is you have this address, and please remember that in class full addressing we have 5 classes A, B, C, D, E. D and E, they don't have any default subnet mask. A and B and C have subnet mask. So it all starts with IP address. So the IP address has network as well as the host ID bits. Network is all about the network, that is the whole computer being joined, and a particular computer is a host. So this network can be divided into multiple parts. So we call it as subnet. A network divided into different networks, those networks are subnet. Okay. And every network will have certain host, certain computing device or certain computers. So these are called hosts. This is the difference between a network and the host. Now in this example, this is a specially taken example because this is /29. We are talking about classless inter-domain routing. So see, classful I told you, and this is the classless. So we don't have any subnet mask here. Okay. And the rules are that all the IDs or the IP address will be contiguous, division by 0, all these things are there. But whenever you have this /29 or /n, we have 192.16.5.133. We don't have to worry about anything, only /29. This 29 is signifying that the first 29 bits starting from the left or leftmost 29 bits are ones. And the ones are the network. These are signifying the network. And whatever comes after, because 32-bit number is that this one, 32 minus 29 is 3. So if IPv4 is 32-bit, subnet mask will also be 32-bit. So 1 to 29, that is 29 ones, is representing the network. The other remaining, how many are remaining? 3. So these 3 are for the host. So how many total bits are being used to identify the network, and how many total bits identify the host? So now it is clear. 29 in a CEIDR form, the 29 bits, they are identifying the network, and the remaining 3 bits, they are identifying the host in that network. That is the computing devices to whom actually the network or the IP address will be assigned. So there are 2 parts in an IP, network and host. It depends on which class you are working on. Now we have different subnet mask. So there are 3 to 4 questions, and here only the subnet mask will be given. And for this subnet mask, we have to find out number of hosts and number of subnet, that is how many network bits are there, how many host bits are there. Along with this, we have also to tell that if this is of class A addressing, then what will happen? So a network with different parts, which is subnet, and in those subnet we have different people or computing devices. Those are called host. So this is a network. The first IP will always be the address of that network. The last one is the broadcast address. So we always, number of host assignment, 2 will be subtracted. So 2 to the power host bit minus 2 will be the total number of hosts. In all the questions, this we are going to do. So we had 255.0.0.0. What does it mean? This is 255. Okay. So how many bits are there? If you start from left, we just have to seek subnet mask. How many ones are there? So there are 8 ones in the first octet. that is 8 bits are there. So this 255 or 8 1 bit is basically the network address. It will give you the network address. When you will have an IP address, when you AND it with the subnet mask, that will give the actual network. Network bits are computed by ANDing the subnet mask with the IP. How many ones are there? 8 ones are there. So this 8 bit are for the network, they are actually network bits or subnet bits. Total 32 bit address is there, or 32, you can see this subnet mask. 8 is for network. Always IP will be of network plus host. So when you subtract this 8, which is actually the network bit, from 32, it will give you the host bit. If we AND this 255.0.0.0 with any IP, especially I am talking about class A, the first 8 bit will give you the network. 32 minus 8, which is 24, is for the host bit. Okay. So 8 plus 25, this always have to be 32. That is in the case here also. So 24 host bits are there, and with the formula 2 to the power host bit minus 2. So number of hosts per subnet will be 2 to the power 24 minus 2. First and last address we cannot assign to any system. So this is 2 to the power 24 minus 2. Now, if this is a class A, just as imagine, this is a class A subnet mask, then what will happen? How many network will be there? See, 8 are the, this is a default subnet mask for class A. 8 bit are already used. So 8 minus 8 is 0. So you just have, for the subnets, how many are remaining? 2 to the power 0. One network, only one single network. So now the subnet mask is having certain number in the second octet also. So now the subnet mask is basically used to find out the network address from IP. It does not find out the host ID. Please remember, host IDs are the byproduct of subnet mask being ANDed with the IP address. ANDing means 1 1 always 1, otherwise always 0. 1 0 0 0 1 0 0 0 0. Alright. So number of hosts per subnet and number of subnets we have to find out. If the subnet mask is this one, we are not being told that what kind of classful addressing we are using. So now let me write it and then you will understand. 255 will be what? 1111 1111. This is the binary representation of 255. How this 240 will be formed? Most of the questions which are coming are based on this only. The 240 you will find out. So this is see. So we have 240. This is the best way to convert it is to make a box of 8 parts, that is 8 bit. The first one will be 2 to the power 0, that is it will have the value of 1. 2 to the power 1, 2 to the power 2, 4 2 to the power 3, 8 2 to the power 4, 16 2 to the power 5 is 32. 2 to the power 6 is 64. 2 to the power 7 is 128. Now, how to convert 240 into binary? This 240 will be found by 128 plus 64 plus 32 plus 16. So 8, 4, 12, 12, 2, 14, 14 plus 6 is 20. So 2 carry. Now this is 10, 10 plus 4, 14, 1 carry. So we have 240. This 240, wherever the numbers we have added, just put 1. Others 0. So 1, 1, 1, 1, 0, 0, 0, 0 is the binary configuration. So 1, 1, 1, 1, 0, 0, 0, 0. Then again 0 8 times and 0 8 times. Okay, you know about this. 8 bit, 8 bit, 0, 0, 8 times. Now this is 8 ones. These are 4 ones. 8 plus 4 is 12. So 12 ones, or you can say this 12 is for the network, or these are the subnet ID bits. 32 bits in all. Subtract this 12, you will get 20. 20 is for the host. Okay. So how many hosts per subnet is possible? 2 to the power 20 minus 2. First and last you cannot use. Now, if this particular subnet mask belong to class M, we are imagining now. In subnet, in the class A addressing scheme, the first 8 bit from the left is for network ID. How many extra we are using? 4. That is how many you have borrowed from the host. If this is a class A, then the second octet, third and fourth, they are not used for the network. So the second octet, which is actually for the host, you have borrowed 4 of them. So this 4 is used for the subnetting. How to find this? If this is class A, 8 bits can be used. Okay. In all you are using 12. So how many extra bits you are using for subnet? 4. And this 4 bit will tell you how many subnets will be formed, how many networks will be formed. Okay. So how many networks it will be? 2 to the power 4, that is going to be 16. So how many networks will be there? 2 to the power 16, 2 to the power 4, that is 16. So 16 subnets or 16 network parts. Next one, now we have 3 octets having certain numbers. Previously first, then 2, then 3. So the first 255 is 8 1 bits. Next 255 is 8 1 bits. 254 is what? See, 254, how to add certain numbers of 2 to the power to get 254. Again the same thing we'll do. We'll make a box. We know the weight or value of each box, and we'll see these values, how many of these values will add to 254. And all these values, the places will be kept 1, the places will be assigned 1, others will be 0. So 1 1 1 1 1 1 1, all of these, only 1 we have left, because 2 plus 4 plus 6, 8 plus 16 plus 32 plus 64 plus 128 will give you 254. If you add them, you will get 254. Only 1 is remaining because you know 255 is all ones. So if you just keep 1 away, that is if you don't include the last one, all ones except this last one will give you 254. So the binary conversion is quite easy. So we have 7 ones and 1 zeros. First 55, 8 1 bits. 255, 8 1 bits. 254, 7 1 bits and a 0. And then we have 8 zeros for last 0. So 8 plus 8 plus 7. How many ones do you have to compute? How many ones are there? So 8 plus 8, 16. 16 plus 7 is 23. So number of ones are 23. In subnet mask, the number of ones will tell you how many network bits are there. So network bits are 23. Okay. And what will be the host? 32 in total. Just subtract these 23. You'll get a 9. So number of host IDs is 9. And number of hosts is 2 to the power 9 minus 2. Now this is a borrowed. This 7 you have borrowed from the third octet. But if this is a class A, just imagine that if this is class A means first 8 bits from the left of first octet is always network. B, C, D means the second, third, fourth. These are for host. 255 is fixed. Total is 23. If it is class 8 you have to subtract because only 15, this 15 you have borrowed from the host bit. If this is class B, 255 will be network, then you have host and host. If this subnet mask is of class B, what we have to do? See, it will not be 15 then. It has to be 23 minus 16 because the first 2 octet will tell you the network address in class B. You have to subtract 16 then. And if it is class C, you have to subtract how many? Well, this will not correspond to that example because this is not 255 in the third octet. But if we assume it to be class A, first octet is for network. So you have to subtract that. And it will be 15. 2 to the power 15 will be number of subnets. This is class A. Now consider this subnet mask. So we have all the octets filled. 3 are with ones, 240 the last one. So class A, network host host host. Class B, network network host host. Class C, network 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 host. So this is the formation for class A, B and C if this is the subnet mask. So if you are taking class C, you know that the first 3 will be for the network. The last one will be from host. Default subnet mask is for class C is 255, 255, 255, 0. So we are not being told that which type of subnet mask it is. We have to find out the subnets and the host per subnet. So we have 8 1 bits, 8 1 bits, 8 1 bits, and 240 we have just seen 1 2 3 4, then 4 zeros. So 4 ones and 4 zeros. If you start with the left. So first 3 octets ones, last octet 4 ones and 4 zeros. So how many ones are there? 24, first, second, third octet, and 4 in the fourth octet. So 24 plus 4 is 28. So we have 28 as the network ID or subnet ID. Total is 32. How many are remaining? 32 minus 28. So you can also say that this 4 we have borrowed from the host, and that borrowing will give you subnets. So 2 to the power 4 minus 2, that these number of hosts per subnet you can assign. If this is class A, let us assume that this is class A. In class A, the first will be always network. Okay, so you don't have to worry about it. You just subtract this from number of ones. How many number of ones are there? 28. Subtract 8, you get 20. That 20 will be used for the subnets. That is, if it would have been class B. Then the first 8 this 1 bits, second 8 1 bits, this has to be subtracted. 28 minus 16. And if class C, 28 minus 24 has to be done. 8 8 8. Okay. So 2 to the power 12 in the class B case, 2 to the power 4 in the class C case. You have subnetted your class C network. This is your class C network with a subnet mask of this. So it is being clearly given that this is class C and subnet mask is also given. We have to find out number of networks. For example, a department organization can have finance department, HR department, the security department. So how many departments, that is number of networks, we have to find out. And how many people, how many computing devices are to be assigned or can be assigned the IP address, that is the host per network. The full range of first 3 networks we'll find out, and the usable address range from these first 3 networks. So how have we arrived with network and host 16 and 40? Let us see. 255 is what? 255 is what? 255 is what? All ones. 8 ones. So 1 to 1 8 times. 1 to 1 8 times. 1 you have to write 8 times. I'm just doing it in shorthand form. Then 1 again 8 times. 240. If you remember, 240 was 4 ones and 4 zeros. Alright. Now this is class C. Class C means first, second, third will be for network. This is fixed. First, second, third, this masking will be for the network. So 255.255.255.0 is actually the default subnet mask for class C. Now you have borrowed how many from the host? Last one is for host. 4 bits you have borrowed. So 2 to the power 4 is 16. So 16 subnets or networks are there. Clear? How many zeros are there? 4 zeros are there. Again, this is for host. But how many IPs you can assign? 2 to the power host bit minus 2. You have to subtract 2. So 2 to the power 4 is 16 and minus 2 is 14. So 16 networks and 14 hosts. Clear? And also you have to list the full range of first 3 networks. Okay, alright? So we have 192.168.1.0. So we have to 16 we have to do. So 192.168.1, you can, if you start from 0, it will be 15. This is the first range. 3 range we have to give. I am telling you about the first. What is the usable? For first and last you cannot use. First is the network address, and the last one is used for the broadcast. So usable is 192.168.1.1 and 192.168.1.14. So 192.168.1.114. So the others one will be, one is 0 to 15, the other will be 16 to 31, then we have 32 to 47. Usable will be what? 16 and 31. No, 17 and 30. 33 and 46, because the first and last we cannot use. Alright. On a local subnet with 255.255.224.0 subnet mask, what is the maximum number of IP addresses that can be issued to hosts? The host you have to tell. Just write this, if you want to do it by yourself, I've already given the answer. But if you want to understand how this value has come, let us understand. 255 is what? 11111111, 8 times. Second one, 255, 11111111. Third one, 224, if you remember, 128 plus 64 plus 32. So 1110000. If you add this, you'll get a 224. I'm adding it, and you know already that it is going to be 224. Why I am telling you about this 128, 64, 32? Because this is the, from left, these are the 3 bits which needs to be on to make it 224. And then we have 5 zeros, 3 ones and 5 zeros. And what is the last one? These are 8 zeros. Alright. Now, what do we have? 255. This is 258. This is 224 and this is 0. How many hosts can it be? All the ones in the subnet are for network. All the zeros in the subnet are for the host. Alright. So number of ones are there. 8 plus 8 plus 3. 19 is for the network or the subnets. This is for network. How many are for the host? Total in all we have 32. Okay. Now subtract this 19 from 32, or you can just compute how many zeros are there. 5 plus 8, 13. So 13 zeros are there. 32 minus 19 is also 13. So this 2 to the power 13 minus 2 you have to do. This is minus 2. Why? Because 2 addresses, first and last, cannot be assigned. So it will be 8192 minus 2, that is going to be 8190. Suppose an organization wants 6 subnets and each subnet has at least 22 hosts. What subnet mask should the organization use to fulfill the above condition? So let us take one by one. We have a network. It has to be divided into 6 smaller networks, or they are called as subnets. So I am dividing it into 6 parts. And every part should have at least 22. That means it cannot have 21 or 20. It has to have 22 or more can be there. So 6 subnets. Along with this, every subnet should have 22 hosts. What subnet mask should the organization use to fulfill these conditions? Everything is of 2 to the power. In order to get 6 subnets, 2 to the power 1 no, 2 to the power 2 no, 2 to the power 3 yes, 8. So you need at least 2 to the power 3, that is 3 bits for the subnets. 2 to the power 3 is 8. This power is nothing but number of bits. So 2 to the power 3 will give you 8, which is somewhat equivalent to 6. So we need at least 3 bits to be borrowed from the host in order to get the subnet. So host bit, see 111 I always told you is for what? 111 is for the network. But in order to subnet, we have to borrow this one from the host part. The answer is this one. How this answer has come, you will just understand. So 255, 1 8 times. 255, 1 8 times. Then we have this again 255, 1 8 times. And the last one is, which is the last octet. We have 128, 64 and 32. I already told you when you add this, you are going to get 224. So 3 bits are 1 and remaining 5 bits are zeros. So we have borrowed 3 bits from the host bit of the last octet, and that is going to give you how many subnets are there. Subnets will be 8. We need 6 but we are getting 8. How many zeros are remaining? 5. 2 to the power 5 is 32. How many we can assign? 2 to the power 5 minus 2. 2 to the power host bit minus 2. So it is going to be 30. 32 minus 2 is 30. Now this 30 is equivalent to 22. We need at least 22. So we have 30. So there is a possibility of 30. But we need at least 22. It can be higher. The subnet mask of subnet network is this: 255, 255, 224.0. IP address of the host in the subnet is this one. What is the number of subnet in that network? So subnet, in order to find out the subnet, you just have to know how many bits are being borrowed from the host bit. Okay. So since it is already given, it is 162.255.98.83. From here it is very clear that this is a class B IP. How do you know it is class B? Because we know 1 to 127, 127 till 192, 192 till 223. So 255 is 8 ones, 255 again 8 ones, 224. We have 3 ones and 5 zeros. Last one is 8 0 bits. How many ones are there? 8 plus 8 plus 3. So 16 plus 3, 19. Okay. Now, in this subnet, this is a class B IP. So the first and second octet will be for network. Third will not be for the network. Because 162 is in between, means it is class B. 1 to 127, as I told you, is class A. 127 to 191, it is class B. 192 to 223, it is class C. So this is class B. And class B, the first 2 octets are for the network. The next 2 are for host. So you are actually taking 3 bits of host, and these 3 bits will be employed for what? For making subnet or networks. So 2 to the power 3, which is 8. These are the number of subnets in the network. Alright. 2 to the power 3, because this is coming from the host bit. So this 8 is the answer, not 2 to the power 8, not option B. So let me just correct this. This is not B, it is 8. So I have corrected it. It is 8. Answer is 8. Number of subnet in the network, because the question is asking about subnet. And how many hosts are there? See, we have 5 zeros, sorry. Then this 8 zeros of 8 and 5. So 13, 2 to the power 13. is your number of hosts minus 2 number of hosts can be assigned in these 8 networks. If the subnet mask is this one, the number of subnets is X. So a network has different subparts or subnet, you can say. The number of subnet is X. The number of hosts in each subnet is Y, that is number of computing devices or people, computer whose IP has to be assigned or will be assigned is Y. Class C is always about network host, because the question is saying about class C specifically. So every subnet will have Y host. So what we have to do is we have to find out X plus Y, that is number of subnets or number of networks plus each host, a possibility of host in one network that has to be added. Class C means the default is 255.255.255.0. So we have 1 to 1 8 times, then 1 to 1 8 times, then we have 1 to 1 8 times, and then we have 224. 224 is 111.000.00. So 3 ones and 5 zeros. Now, since this is class C, we don't have to worry about the first, second, third. We have borrowed 3 the bits from the host, and whenever we borrow these ones from the host, that is going to be subnets or networks. So 2 to the power 3, which is 8, is the subnet. This bit 2 to the power those number of bits is subnet. X is 8 now. 5 zeros are remaining. That is 5 2 to the power 5 minus 2. These hosts can be assigned. So this 2 to the power 5 2 to the power 5 is 32. 32 minus 2 is 30. So 30 is your Y. These are the host can be assigned. X plus Y is 30 plus 8. The answer is 38. Alright. So this is all about subnet and subnet masking question answer. Thank you so much and take care of yourself.